Thank you for watching Hack the File. I'm Michael Lopez, and on today's episode, we're going to um, mess with encoders in the ethical hacking book series. Enjoy. All right, so we're back on the ethical hacking book series. Um, like I said, if in this series we're missing a video, that means that YouTube took it down for some reason or other. Um, so I'll go back and see if there's any way I can redo it and do something different. I don't know, but we're moving on. So let me get all my ducks in order. All right, so this is where we're at. Evading antivirus by using encoders. Won't antivirus software detect these malicious programs? Not always. You can see which antivirus software will detect your implant by uploading it to VirusTotal at https://virustotal.com. Now, I've gone over VirusTotal before, and um, basically, it's a website that where you can check to see if like URLs or um, files are malicious, and we can actually do this and see, but we're gonna skip that for now. But we can click on VirusTotal, and this is what VirusTotal looks like. I've already got it saved on my page, and like I said, you can choose a file here. You can choose a URL and put in a URL. You can search domain IP addresses, anything else, right? And it'll tell you if it has a virus, or if it's like known but for being malicious. Oh, why is this moving so much? Okay, so let's give you an example. Let's do what about LinkedIn? So we'll do URL. We'll do LinkedIn.com, and it'll say no security vendors flag this URL as malicious, right? And it gives you you know one company flagged it, and then it's been cleaned by a lot of other companies, right? And then you can go to details, and it'll tell you more stuff about it, details, and then the community, it'll tell you what's going on in the community, and India connection, and some more information, right? So that's an example how VirusTotal works. Now it's saying that I can upload my virus that I made in here, and it'll tell me, but I'm not going to do that. I'm sure you can. Okay, so antivirus systems use signature detection to attempt to find malware. A malware signature's unique sequence of bytes and that represent it. You can see our malicious implant byte sequence by running the XXD command. So malware XXD malicious. Let's do that. So I'm gonna come here. We'll go to my Kali. I've got hack the file. And then we'll go to Trojans. Server malware. Here's the malicious, and then I'll open a terminal here. Wait a minute. What was it? Malicious? Man, it got hot real quick. XXD malicious. There it is. There's your Christmas colors and everything, huh? There's your malicious thing, right? Let's see what that looks like. Malicious. Antivirus software detects malware by scanning the memory for these signatures, so you can avoid detection by ensuring that your malware has a signature not known to antivirus systems. One way to do this is running the malware through an encoder. Encoders change a program's signature by modifying its bytes without changing its functionality. You might be wondering, why wouldn't we change the bytes, change both the instruction and the program's functionality? Well, two programs can have the same functionality even if they don't use the same instructions. For example, both of these programs multiply a number by 2. A equals A plus A equals A times 2. Let's make this idea concrete by applying a simple encoder. MSF Venom supports several encoders. You can view a list of them by starting MSF console and running the show encoders command. MSF console minus Q show encoders. Let's do that. Encoder command PowerShell command encoder. Excellent. PowerShell. Okay, let's see what it says, what it wants to do. Let's take a closer look at the two encoders shown in this output, starting with the easiest one, the base64 encoder. The PowerShell base64 encoder uses the base64 coding scheme, which converts binary sequence to text. Just like the ASCII encoding scheme mentioned in Chapter 5, however, unlike ASCII, which converts 8-bit sequences to the base64 encoder converts 6-bit sequences to one of 64 possible printable characters. Consider the example, the T10, which converts the Linux list command from ASCII to base64. Okay. The last section has only 4 bits, so the remaining 2 bits are assumed to be 0, and the padding character equal is added to the end. Here is the base64 encoded result, BHM equals. Can we execute this base64 encoded value? Yes, if we decode it and pass it to the shell before we run the program. This command passes the base64 encoded string to the base64 decoder D, which converts the string back to ASCII encoding before piping it to the shell to be executed. Figure 10.7 shows an overview of this encoding and decoding. So why does it want me to run this at the padded character? Here's the basic result. We can execute this basic. BHM. So it encoded this. They ran this to run it. I don't know. So okay, so the list encoder base64 BHM decode base64 D BHM passage. A bash script containing the ls command will have a different signature from a file containing the base64 encoded values of the base64d command, even though they are functionally equivalent. This is because both files are stored using the ASCII encoding. Because the signatures are different, an antivirus program will fail to detect the malicious file containing the base64 values as described. Yeah, that makes sense. However, there is a weakness to this technique. Once the signature detection algorithm captures an encoded implant with a new signature, it will be able to detect all future instances of the coded implants. Because the base64 encoding never changes in the Shikata the encoders section of this chapter, we'll explore how to create a polygraph encoder that generates a new signature each time it runs. For now, let's complete the discussion of the basics for encoder by writing an implant, and then, as an exercise, we'll create a Metasploit module to encode it. Create a new file in the malware folder called implant. Okay, wait. For now, let's complete the discussion of the basics for encoder by writing an implant, and then an exercise will create a Metasploit module to encode it. Create a new file in the malware folder called implant.sh. Let me see. I feel like I've done this before. I hope not. Maybe this is the video they took down. Okay, let me see. Here's, yeah, implant.sh. Create a new file in the malware folder called implant.sh and copy in the code snippet that follows. The script will use telnet to establish two connections. It will receive commands from the first connection on port 80 and upload the results using the second connection on port 443. Okay, but did I enter in that? Let me see. Oh, okay, so I was just setting it up. I think this is as far as I've got. Let's see if we can. Let's see if base64. See what snippet this is asking. Echo telnet. See echo telnet. It's chapter 10. All right, let's just enter that in. Man, I can't see. Gotta get up. All right, let's see if that's right. The script will use the telnet to establish two connections. It will receive commands from the first connection on port 80 and upload the results using the second connection on port 443. Is that what it says? Yeah. Port 80, port 443. Yeah, it looks about right. Use the netcat utility to create two TCP servers in separate terminals. What? Use the netcat utility to create two TCP servers in separate terminals? So, netcat. I don't know. We'll see if that's right. Writing a Metasploit module. Let's write a Metasploit module that will base64 encode the implant. Metasploit modules are written in the Ruby program language. Don't worry, Ruby looks a lot like Python, so you'll pick it up easily. Also, the Metasploit framework is open source, and you can view the command PowerShell Basics for Encoder by visiting HTTPS, GitHub, Metaphor, blah, 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 blah. Let's click on this. Save that. can view the command PowerShell encoder. This encoder is used to encode PowerShell scripts for Windows machines. Take some time to look at PowerShell basics for encoder before we begin to write our own version that encodes Bash scripts for Linux machines. Create a new folder in your malware folder called Encoders, and then create a new file called Bash Ruby. Inside the Encoders folder, we'll implement our basics for encoder in the file. So copy the following. Oh crap! So let's see if we have this. I think we do. Yep, we got that. Boom, 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 boom. So I won't have to write that. All right, let's do that first. Encoders. All right, so we got lucky because we have the code right here in the book chapter, GitHub, which is awesome. There it is. I don't have to write that or nothing. Now, Ruby has a little Ruby and everything. Now, with anything, we gotta kind of look at it and see if it looks right. Because when you copy and paste it, sometimes it doesn't line up, and you're gonna have running errors. So I'm just giving this a little one over. Sometimes they have errors in this GitHub too, where they don't do something right. We've already encountered that. So you kind of got to just look at it yourself. And this one looks good, actually. Okay. Take some time to look at the power. Okay. Alright. We inherit this from the encoder superclass and then specify the rank or quality of the module. Normal ranking. Modules range in quality from manual to excellent, depending on the reliability and amount of human intervention needed. We use the super keyword to call the superclass constructor and provide information on our module. After our module has initialized, the Metasploit framework will split the inputs into blocks and call the encode block function. Encode block state above. We convert the values of the ASCII Unicode before basics for encoding them. Hold on. To test your new encoder, add it to the Metasploit framework by copying it into the Encoders folder, which you can find by opening your file explorer and navigating to User, Share, Metasploit Framework Models, Coders. Bash, let's save the bash. Okay, let's do that. First, let's see if we have a connection. Alright, we do. What the hell was that? Okay, now come on here and we'll convert device. Okay. File Explorer. Oh, I thought it said there. Where's the user? User's gonna be Kelly, I think. Home, right? It says it's gonna, it wants me to look at user share. User share Metasploitable Metasploit framework. Modules in slash encoders. Create a new folder called Bash. Oh man, it's not gonna let me. Bash? Hold up. Bash. Alright, I just copied this one over to this one because it had permission problems. And I just used sudo copy, so cp there, and then I piped, or not piped it, but I used the right caret to send it over to this to the directory. And it worked. So there it is. Alright, I will. If you didn't see how I did that, you can rewind it, go back, but basically I just copied it from here and sent it over here because I couldn't drag it. I couldn't do the easy way out because this had permission problems. Didn't let it do nothing. Now let's go back to here. Oh. All right. open it. Okay, wait. Create a new folder called bash. Save that in there. Here. Open a new terminal and run the show encoder command in the MSF console to ensure that your module was correctly added. We're looking for this one, I guess. These are still listening. So we're looking for the bash/bash 64. Do you see it? Show encoders, right? Let's see. PHP base 64. Bash. Bash base 64. I don't see it. I don't see it. Didn't matter, right? It's on there. Let me see. Oh yeah, right there. Yeah. Encoder bash 64. Alright, looks like it works. I added it, so now what does it want? Manual, no. Normal. Bash is for a crew around. I don't see no manual. Oh, normal rank. If your module is present, use MSF Venom and your module to encode your implant. Run the following command to create your encoded implant and save it as implant encoded. Malware implant.sh MSF Venom encoder back. Let's see. Where's my implant though? Right here, right? This is my implant. I've got my bash encoder code there. We're going to open a terminal here. And we're going to say implant .sh. Message Venom. Oh, excuse me. Payload. Alright, let's see what happens. ARCH. Why is that not running? Implant. Implant.sh. So I can't get this crap to work. I've been working on it for a minute. I'm not gonna waste any more time on it. I'm gonna move. This isn't. It's basically you're encoding something. The piping command doesn't want to seem to work on this MS Venom, so we'll come here. This is another day, by the way. I had to work on it for a while and then I called it quit. So here's the implant. I'm gonna open terminal here, and here's the command they want me to enter, right? Problem is this this pipe doesn't work. It won't pipe this implant over to MS Venom, right? And then run all this crap. And I added Windows on the platform because why not? So, and I took the payload off because there's no payload. We're just encoding. So I don't know why I had the payload on there. Like I said, a lot of these commands are obsolete and don't make sense, right? So this didn't work. Couldn't get it to work. Um, okay, so this one says implant.sh, the implant, and then they want to pipe it to MS Venom, payload, nothing arc, this platform. So why is payload in there? It's not a payload, right? So I took that out. First off, I mean, you're gonna get an error every time you run this. You're gonna get an error saying that Arch is not a proper payload. So why is this in here? So like I said, human error books. They're not all perfect. Was the purpose of my channel. So I took this out. This piping does not work the way this command says it is. Okay, this is not a proper command, or it won't pipe it for some reason. I have no clue. So you might have to try to encode this with base 64 a different way, not using MSF Venom. Okay, or maybe going back and seeing using this command. See this in your bash shell or something. I don't know, but this all. I mean, I spent a lot of time on it. I don't think it matters because it's like it even says in the book, it's obsolete. I mean, it has a flaw, right? Test your encoder implement, make it executable, run it. I did this, ran it, and I can't get anything, right? You've written your simple base 64 encoder. However, it has limitations. So I mean, I'm gonna skip it. I mean, none of this is working. I don't want to go back and find another way how to encode this. I mean, there's a lot of different ways you can look that up. It didn't work at all. Okay, like I said, it might be obsolete. You know, I encoded it one time, and all it did was add this into this to the to the file, but it didn't pipe over that existing file. So I added the code, and I tried to do it manually and stuff, and everything, but it still didn't work. But we're gonna skip it. I mean, it's not that important. Like this is, like I said, it's obsolete, right? You don't want to do stuff that's obsolete, anyways. If you're trying to invade antivirus, most likely you're gonna use the next thing right here, right? And you're gonna encode it. You're not gonna just encode it like this, which this would be for, let's say, decoding, encoding, decoding, whatever. But it still didn't. I have to look up some more, and it's going to take a lot more research dedication to figure out, more than I care about, to figure out why this command's not working either. I tried to run that didn't work. So I'm basically going to move on. All right, let's go to here. Shikara Ganai encoder. So this is probably this is going to be the one we're going to be using anyways, because the other one, like I said, is obsolete. The Shikara Ganai SGN encoder encodes payloads by XOR in the bytes in the payload with a randomly selected number called an initialization vector. The strategy is similar to the one-time pad encryption algorithm discussed in Chapter 5. However, the SGN encoder includes the initialization vector and decoder code as part of the payload, so it loads the initialization vector and then starts the decoder when the payload runs. The decoder loops through the memory addresses associated with the encoded part of the payload and decodes an instruction by XORing it with the initialization vector at each iteration of the loop. The decoder then replaces the encoded instructions with the decoded instruction in the memory. Once all instruction has been decoded and replaced, the decoding loop ends and the CPU executes the decoded region. Because the decoder is usually partially encoded, it's difficult for an antivirus program signature detection algorithm to identify the payload based solely on the decoder's signature. The SGN encoder can make I guess that's going to be the short. The SGN encoder can make the reverse engineering process more difficult by calculating a new iteration vector for each instruction. For example, it can add the newly decoded bytes to the previous initialization vector as shown in figure 10.9. Random initialization vector XOR byte 1 byte vector XOR byte 2 byte 2. Okay. The SGN encoder further complicates the reverse engineering process by using additional arithmetic additions and subtractions to compute the initialization vector. The SGN encoder is often referred to as a polymorphic encoder. A polymorphic encoder will generate a new signature each time it runs, as long as a hacker selects a new initialization vector and runs the encoder for multiple iterations. The following command generates an SGN encoded payload. Remember to replace Kali IP with the IP address of your Kali machine. Sudo MSF Venom, a architecture, platform, Linux, interpreter, reverse TCP host, listening host, with listening port, encoder 86, Shikata Ganai, elf, malicious. So where does he want me to create that? Do we want to do one? We want to try to run that in. He did it in his malware, so I guess we'll do it in our malware. All right, let's run that. So malware, malicious. We'll call it malicious 2. Right? Open up a terminal here. Sudo venom -a for the architecture x86, then the platform. Linux. It's kept Linux. Just okay. The payload Linux /86 interpreter. Have I done this before? Oh no. Okay, so this is just a little different. lhost equals port equals using 443. We're gonna encode it. Coder. Shikata. 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 Ga. Nai. Shikata ga nai. On 4 F. Oof. Oh. Capital malicious. See what happens. Found one compatible encoder. Attempting to encode payload with 4 iterations of Shikata Ganai. See, that's what that was. That I was the iterations. Shikata Ganai chosen with final size. Payload size 231 bytes. Size of ELF 315 bytes. Saved as malicious. See, now this is what I like to see. See? All that other crap, I don't know what was going on. We've used the encoder option. Let's go back here. We've used the encoder option to specify the SGN encoder. One. Encoder. Okay. Let's see if it created my malicious. I want to see what's in it. How can I open this? Well, it's gonna be eh. Anyways, it created it and it encoded it. That's what we're trying to do is use the encoder function to create a payload or a um, malicious file. All right. Do we want to stop here? Or we want to move on. I think we're gonna stop here and then we're gonna go to the next one. Creating a Windows Trojan. We'll create a Windows Trojan next. I mean, this is a very long Android Trojan. I think will be exciting. Then we'll test it. But this is going to be broken up into different videos. I don't like going into hours and hours, but this is something we have to take our time with, anyways, because this is a very cool thing to know, and you need to know how we're doing this. If you ever get an interview or something like that, and they ask you, how do you avoid antivirus? What's one way you would avoid antivirus? You can tell them with encoders um, and the Shikata Ganai encoder, or using MS Venom to create a malicious file, and you can sneak it in. And we've learned so much already from this chapter. You can put it in the. Even though I couldn't get anything to work so far. I mean, I got most of the stuff to work. I just, couldn't get it to work the way it's supposed to function. And I think that's just scripting errors. This one, I think, is a command error where we have to go in and figure out how to take. And then that's easy. I could just type in, how do you encode a malicious, file using MS Venom. And this one, why do that when we can just create one, right? We just did. So instead of like trying to take the plan and coding it, but you want to know how to do that too. Well, we can just create one, right? With this payload in it, I guess. Where is it at? With the reverse host payload, and then encrypting it. Or you could just take the payload out and see if you can use that to encrypt it. I don't know, but that's fun. You can mess with this on your own. See, this is your own stuff. Like, I can get it to work, and I'm gonna do this later. Maybe redo the video or whatever, do a follow up. But you can just mess with it on your own. But yeah, I think that's good. I'll see you the next time. I hope you enjoyed.